yesterday, we plotted polar points. Today, we're going to change from rectangular to polar, and from polar to rectangular. All right? Rectangular points are the ones we've done forever, which are x, y. Polar points are the new ones we did yesterday, which, do you remember that was r theta? Okay? So, first of all, we are going to go from polar to rectangular. Okay? Let me ask you if you remember something. Do you remember that sine of theta was equal to y over r?
Yes.
What was cosine of theta? Now what happens if I multiply this equation by r?
R and y.
Does y equal r sine theta? For this one, does x equal r cosine theta? So these two equations is what I used to go from polar to rectangular. All right? Can I show you what I mean? That's nothing new to learn, is it? You already knew that. So if I give you the point 8 5 pi over 6, what is r? 8. What is theta? 5 over 6. Everybody agree? So I need to find, this is r theta, I need to find x, y, right? Didn't we say y is r sine theta, so y is 8 sine of 5 pi over 6. Oh, your calculator ain't going to help you.
Is it?
Uh-uh.
Oh,
What? Well, because it's going to be, your answer's going to be in radicals. Right here is x equal to
oh, because sine of pi
8
over 6.
cosine of 5 pi over 6. Is it 5 pi over 6?
Is it the second quadrant?
Is in quadrant 2
So it should be
with a reference angle of
pi over 6.
pi over 6. What's this side right here? 1, 2, and
Radical 3.
negative radical 3. So is it y equal to 8 times 1/2?
Which is equal to 4.
Okay.
So it really only works out for this one specific problem.
Yes. What is x? 8 times what?
Negative radical 3.
So my polar was 8 5 pi over 6. My rectangular is what? What is my x? What is my x value?
4 negative.
Negative 4 radical 3? What is my y? 4. Now, if you notice, they really line up because I want you to think a minute about polar. 8, 5 pi over 6. Is that in quadrant 2? Okay, when we did the polar, didn't we say 5 pi over 6 was here? And so it was about right there. Where is this point? Here?
That's crazy.
So they line up. They're the same spot. They're just listed as rectangular or polar.
How does this make so much sense? Can we do another problem?
Oh yeah, oh yeah,
Because I'm not, yeah, little.
oh yeah.
This is definitely the easy part. Because going from rectangular to polar is
A little more thinking. You are correct. You are correct. Let me. I'm trying to make us draw a different triangle.
different triangle.
Yes. Okay, what is y equal to? Negative 1.2 sine of 5 pi over 4? Chandler, do you agree? You zoned out on me a minute.
I did zone out.
Is that right? What is x? Okay, I can draw the triangle pi over 4. But do you all know sine and cosine of pi over 4?
I can figure it out with this small amount of thinking.
That's the one you're supposed to know, right?
Oh, yeah. Well, 4 is easy. So it's,
That's the easy one. Now, the question is the sign of it positive or negative?
It's positive because negative 1.2. The sign is
No. Not the whole thing. Just this.
That's probably. Wait, no, it's more than.
Isn't it in quadrant 3?
All students take, so it's negative.
So it's negative. So negative 1.2 times negative radical 2 over 2?
Yes.
Okay. Which is, by the way, 0.6 radical 2? Cosine of 5 pi over 4.
Negative radical 2 over 6.
The same thing? So, what is my point?
6 radical 2. 6 radical 2.
Uh-huh.
I don't like finding a radical.
I'm sorry. It has to be exact. Once again, let's think about this point. 5 pi over 4 is down here, isn't it? And I'm going to go opposite, so I'm going to end up there. Right?
Oh.
Where is this point?
There.
Same quadrant?
Wait, how do you graph radical 2 though? Like how do you get it?
Isn't radical 2 about 1.4?
But you don't really need to know that to figure out the answer.
You just know it's a little bit to the right and a little bit up.
Yes. We're just thinking of where it would end up on the graph, not exact value where it would end up. We want to know about where. Does that make sense? Can I throw one more of these at you before I move on? Make you think a little bit on this one, all right? So y is 7 sine pi over 2, and x is 7 cosine pi over 2. And you notice you have to be careful because do you see that every time I've done y first? But when you write the point, you have to write xy. And I do y first because I always do sine first. I don't know why, I just always have. But be careful and pay attention to which one's x and which one's y. Right? Okay, what is the sine of pi over 2? Think about the sine graph. 1. Okay? So y is 7. Yes? X. What is the cosine of pi over 2? 0. So x is 0. So my point is 0, 7. Then where would this point be? Straight up? Where would this point be? Straight up. That's how those graphs work. Now, that was polar to rectangular.
I'm not looking forward to it.
You ready to go the other way? Ah, goodness. Rectangular, it actually isn't as difficult as you want it to be. Because of Pythagorean theorem, do you agree with this? Because isn't r the hypotenuse? So r would be the square root of x squared plus y squared. All right? Now, how do we find theta? We kind of have to work a little bit with quadrants here to make sure we get it in the right spot. I'm trying to make sure I word it the same way they do. The tangent of theta is y over x. Okay. Those are the two equations. Nothing new on those, is there? All right. Can we do one? Okay. For this problem, we want r to be positive. And it tells you that. We want r to be positive. Okay? So here is my point. Oh, it's not a difficult one. That doesn't make it difficult.
It makes it difficult to look at.
Okay, all right, I'll agree with that. What is r?
Radical negative 3 squared plus 3 radical 3 squared. So is there
It's 3.
No, it's not 3. Is it
0.5?
negative 3 squared plus 3 radical 3 squared? Is that true? Isn't this 9 plus 27.
27. Oh, wait.
Don't I square this and square this? And I multiply them together?
Oh, wait, what do you do? It's
I square the 3, I square the radical 3, and I multiply them together.
I did it.
Which is 36. What is R? 6.
Really? I didn't think so.
Okay, everybody understand R?
Yeah.
Now, tangent of theta is 3 radical 3, and I'm going to drop the negative. All I'm trying to find is my referencing, right? So this is tangent of theta radical 3 over 1. Okay, let's think about this, guys. What quadrant is this point in? Yeah, but I said we're going to make it positive because we're doing reference. What quadrant would this point have been in? 2. So I need this to be in quadrant 2, don't I? Do you agree? Because I have to be in the same quadrant? So tangent, if this is radical 3 and this is 1, right? This is pi over 3. So what is theta? 2 pi over 3? So my answer is 6 2 pi over 3.
Does it make a difference like that since one should be negative?
No, because, well, it would have been here. See, if I'd have put the negative here, it would have been negative.
So you don't put the negative
It doesn't matter. We're worried about the angle as long as we get in the right quadrant. We know that one is negative and that would have worked. When we work with reference, we can drop the negative, but you just have to watch the quadrant. So it'll work either way. Does that make sense?
This isn't as bad as this one. I expected this to be worse. Yeah.
Well, we're not there yet.
Oh, I know. Stop speaking too soon. I need to stay properly upset. I don't know.
Somebody find R. I'm going to let you find R.
Maybe wait until everybody has an answer before we answer it.
Okay, don't say it until everybody has it.
You say that, you're probably going to get it first, though.
I don't think so. This just not making any sense to me, so.
How to find R? It's just put that R in there. What'd you get for R? Do we have it? Nobody wants to say it? 16.
How did we find that?
8 radical 2 squared plus 8 radical 2 squared. You can even type that in your calculator as long as you put 8 radical 2 in parentheses. You're still in a radical. You gotta get out of the radical. See? Well, okay, never mind. Go ahead. I see what you're doing. No, it's not 3, it's 2. Now, that was probably what the problem was.
So whenever you solve for the tangent of theta, like you do the negative 8 radical 2 over 8 radical 2.
What does that reduce to?
Negative 1.
Okay, negative 8 radical 2 over 8 radical 2. So tangent of theta is negative 1. When is tangent 1? Gotta know that one. 45 or pi over 4, isn't it? Now, what quadrant is this in? So I need pi over 4 right here, don't I? What is theta? So my answer is 16, 7 pi over 4. We knew this point was in quadrant 4. We look at the whole point.
Could it be wrong if you just put negative pi over 4?
Yes, because it asks for your answer to be between 0 and 2 pi. If they didn't ask for that, no, it would not. So just depending on that. Okay, we've got this down. We're good? Because I'm going to throw a little bit harder at you before I move on. This time, I want R to be negative. I just looked at my wrist and that's... Okay. This time, I want R to be negative. Okay? This time. And it says specifically R is negative. Because when I square root, isn't it plus or minus? So what is R? Negative 2. Okay? Remember, when R is negative, we go the opposite direction. Correct? So what quadrant is this in? What quadrant is this point in?
2. But if it's opposite,
It's in quadrant 2, and it's opposite, so it must be in quadrant 4. Doesn't R mean go the opposite direction? Isn't that what, if R is negative, isn't that what that means? So instead of going up to 2, I would be down in 4, so I've got to go opposite, right? So you think this angle should be in quadrant 4? Right? And tangent is opposite over adjacent. So what is this angle? So what is So my answer is negative 2 5 pi over 3.
I still don't understand why we went the opposite way.
Okay, when we do R, a positive R means I go towards the angle. A negative R means I go away from the angle.
But how do we know that we're in quadrant 2?
Okay, this point right here is in quadrant 2. So when I plot my theta and my R, I have to end up in quadrant 2. Right? Lily, do you agree with that? But since R is negative, instead of going this way, I would go the opposite way. So if I was in quadrant 2, I would end up down here. So if I start here, I end up in quadrant 2. Right? Now, what I consider the hardest thing you do today. All right? I know. This is quick. Hope. And painless.
That's what people say ripping off a Band-Aid is. And 1,000% is not painless.
Okay. Here is my point. This time, I want R to be positive. I don't know why she likes this point, because personally, I think this point is harder than the last one.
It's not rectangular or polar, right?
This is rectangular, we're going to polar. What is R?
Square root of 40.
Isn't that 2 radical 10? Remember, you've got that program on your calculator, don't you? So R is 2 radical 10, right? What quadrant is this point in? 4? Everybody okay? So I need it to be down here, right? So is the tangent of theta equal to 6 over 2? Yes? Is the tangent of theta equal to 3? How am I going to put that? So is theta equal to the arctangent of 3? Right? Is that right? How am I going to put that in quadrant 4? Is it 2 pi minus that? This is my theta, right? How would I find this? 2 pi minus theta? Would I? So, would theta be 2 pi minus the arctan of 3? So my answer would be 2 radical 10, and then theta would be 2 pi minus arctan of 3. Right? Some of you are frowning at me. Can I word this another way? Can I try again? Huh?
Do we have a decimal?
No, we leave it like that. All right, let's back up. If I had stayed with the negative, and I would have said tangent of theta is -3, right? Once again, when I take the arctangent of a negative number, doesn't that put me in quadrant 4, between 0 and -π/2? How could I get that between 0 and +2π? Could I also have said it is 2 radical 10, and then the arctangent of -3 plus 2π? Either one of these would be correct. No. Just have to get one of them. Said it was the hardest, didn't I?